8:41. There is a yellow car. And a red truck. They are going to collide and stick together. And once they do, they have a final velocity. It's really hard to see that yellow, isn't it? That is 24 degrees. Tell you what, I'm gonna write the symbols. And then put what we know here. Theta is 24 degrees. We'll call this V2, V1. The associated masses. And I'll call this final velocity capital V. That we do know. That is 16 meters per second. And then we know the masses. The question is, what are the initial velocities of the truck and the car? Well, we'll call this state A, call this state B. State A, think of it as right before the collision. State B is right after the collision. The collision takes basically no time. If there was some region of time, this is the interaction time. Think of it as basically instantaneous. So you have state A, like snapshot A, picture A, and then picture B, state B. To go from one state to the other, or one scenario to the other, one snapshot to the other, one moment to the other moment, there is some interaction between the two. That interaction time, or that collision, is near instantaneous for most problems, unless otherwise denoted or described. Pretty much think of the collision as happening instantaneously. So what are these initial velocities? In this case, this is an easy problem. It would be an impossible problem if they didn't tell you what angles the car and the truck met at. So, for example, if this was the car and it was going this way, and they didn't tell you this angle, and then here's the truck and it was going something like this. So you don't know what these angles are. You just know the masses. And you knew after the collision that the velocity magnitude was 16 and this angle was 24 degrees. You wouldn't be able to tell what the angles were before the collision, or what the velocities would have been before the collision. All you can tell from what you're given in state B is that the total momentum for the two vehicle system is m1 plus m2 times the magnitude of the velocity times, and then we'll have sine of theta to give you the x component, and cosine of theta to give you the y component. So this is after the collision, but since momentum will be conserved, because there's no external forces acting on it, it'll also be equal to the total momentum before the collision. So if that was the scenario before the collision, you wouldn't be able to tell what V1, V2, alpha, and beta were, because that would be alpha, beta, V1, V2, 4 unknowns, and only 1 or 2 equations, which is not enough. But in this scenario, alpha is 0, beta is 0. So now you have this equation, and then the equation that you will have for the before, 2 equations and 2 unknowns. So this is solvable as is, this way, but not this way. So just an aside for you. Okay, so what is P total before? That's going to be P of the momentum of the truck plus the momentum of the car. The momentum of the car is m1 v1 I hat. The momentum of the truck, m2 v2 j hat. So P total before will be m1 or v1 I hat plus m2 v2 j hat. So these x components have to be the same, and these y components have to be the same. It's true that P total before is equal to P total after. So if this is true, then the x components have to match. And then the y components will have to match. Oh boy, I didn't do that right. Yeah. So m1 v1 has to equal m1 plus m2 capital V sine theta, and m2 v2 has to equal m1 plus m2 times capital V cosine theta. We know V, we know everything on the right hand side. We know almost everything on the left hand side, we just don't know the velocities. So that says V1 is the total mass divided by m1 times V sine theta, or was it 950 plus 1900 divided by 950 times 16 meters per second times sine of 24 degrees. This is 19.52 meters per second, and then from this equation, it's almost exactly the same. The mass ratio, (950 plus 1900 divided by 1900 times 16 meters per second times cosine 24 degrees. This is 21.93. So, with the proper sig figs, I think it's 3. This would be 19.5 meters per second. This would be 21.9 meters per second. So those are the speeds of the car and the truck.